Hello everyone. In this video, I would like to do some questions from the previous homework. And if you got wrong on those questions, hopefully after you watch my video, you would understand how to solve those problems. Okay. The first question I would like to work is number 1. This is a question ask us to find the mean and the standard deviation for group data. Okay, so to do that, if we go to the StatCrunch, okay, so these are the categories, okay, or the classes, right? We have 7 classes in total. And these are the frequencies, okay? The frequencies of each class. So we go stat, and then we select, we select summary stats, and we go to the grouped data. So there are 2 options we need to select. First one is the name of your categories, so or the column of your categories. So we select savings. Okay, and the second thing we have to select is the frequency. Okay, the middle points, we said the middle points are given by consecutive lower limits. Okay, and then we select the mean and standard deviation. Now, because this is a sample standard deviation, so we select this. Okay, and we'll compute. So the answer are, the mean is 231. Well, we round to the nearest integer, so that's 232, and the standard deviation is 234. Okay. Now, if we do this by hand, we're gonna use this formula, these 2 formulas. So this is for mean, and this is for the standard deviation. So if we do this by hand, okay, we will first need to find what is the middle point of each class. Okay. So the first middle point gonna be the sum of this. Let me see where I can write this. Okay, let me put it here. So if you forgot what is the middle point for what is the class middle point, the class middle point is the average of the consecutive lower class limits. Okay. So for the first class, the lower limit is 1, and the next lower limit is 200. So the average between 0 and 200, that will give us the middle point for the first class. So it's 100. For the second class, the average between 200 and 400, that's 300. Okay, and then we have 500 and 700 and 900. Now this is 1100. Okay, now the next class, the lower limit for the lower limit for the next class gonna be 1400, even though we're not given that. Okay, so we add 1400 by 1200 and divided by 2, that will be 1300. Okay, so those are the class limit, sorry, the class middle points. Okay, and then we multiply each midpoint by the corresponding frequency, okay, and we add the sum, and then we divide by the sum of the frequencies. Okay, so we can find the sample mean. Okay, and then for the sample standard deviation, we do this way. Okay. Okay. All right. So here, again, we're given a group data. Okay, we're given group data, and we are asked to find the mean and the standard deviation. So we open the StatCrunch, and we select the group data. So the column for the class is temperature, and the column for the frequency is days. Okay, we select these two. And because this time we are computing population standard deviation. Now you may wonder, how do I know it's population standard deviation? But by looking at this symbol, we can tell this is a population mean and a population standard deviation, because we said if it is a sample mean, then the notation we use is x bar, and the notation for standard deviation we use is s. So right now we use sigma, so that's why I know this is for population standard deviation. So I select this. Okay, sorry. So I select the unadjusted standard deviation. Okay. So got 79.9 and 7.7. Okay. And since the frequency histogram, we can see this is a kind of symmetric and has a shape of a bell. So we select yes. Okay. Okay. So according to the empirical rule, 95% of days in the month will be between which two temperatures? So we know that if you forgot about that, let me show you. Yeah. So the empirical rule says if the distribution is a symmetric and is a bell shaped, then 95% of data will be between mean minus 2 sigma and the mean plus 2 sigma, right? So here I just need to figure out what are these two numbers. Okay, what are these two numbers? Because so from part A we figure out the mean and the standard deviation. So mu minus 2 sigma is gonna be 79.9 minus 2 times 7.7, and the mu plus 2 sigma, that's gonna be 79.9 plus 2 times 7.7. So that's how we got this answers. Okay. Okay, number 6 is about a weighted mean. So Esther and George wants to make confetti. In order to get the right balance of ingredients for their taste, they bought 2 pounds of paper hearts at $4.25 per pound, and 3 pounds of sparkling stars for $2.69 per pound, and 4 pounds of shiny coils for $2.48 per pound. So we want to determine the cost per pound of the confetti. So for the weighted mean or weighted average, the formula is given by this. So here W stands for the weight for each data or for each observation. Now here, since we want to find the cost per pound, therefore the pound will be our weight. So here we use we use a pound as the weight. So for the first thing, for the paper hearts, the weight is 2. And for the sparkling stars, the weight is 3. And for the shiny corals, the weight is 4. And the price for each item, they are the data, they are the x values. So that's x equals 4.25, x2 equals 2.69, and x3 equals 2.48. So we have 2 times 2.25 plus 3 times 2.69 plus 4 times 2.48, and we divide by 2 plus 3 plus 4. We will get this answer. Okay, the cost per pound is given by this. Okay, for number 9, we're asked to find the z-score. Okay, so let's recall the formula for finding the z-score. So that's the data or the observation minus the mean divided by the standard deviation. Or if we're given the sample's mean and sample standard deviation, it's going to be x minus x bar over s. So the problem says, suppose baby is born after a gestation period of 32 to 35 weeks, have a mean of weight of 2,800 grams and a standard deviation of 600 grams. So for the baby, in this period, so the mean is 2,800 and the standard deviation is 600. Okay. And for a baby born after a gestation period of 40 weeks, the mean is 3,200 grams and the standard deviation is 445 grams. Okay, so we have a baby in a 34 weeks gestation period. Baby weighs 3,000 grams and a 41 weeks gestation baby weighed 3,400 grams. So we want to find the corresponding z-score, and we want to see which baby weighs more relative to the gestation period. So this is after 40 weeks. Okay, after 40 weeks. Okay. So for the baby, the 34-week baby, we're gonna use this mean and this standard deviation to calculate the z-score, because 34 weeks belongs to this category, and the 41-week baby belongs to this category. So x equals 34. Okay. So the z-score for this baby is 3,000 minus 2,800 divided by 600, and the z-score for this baby is 3,400 minus 3,200 over 445. Okay. Okay. So if you do this calculation, you will find these numbers. Okay. And because the 41 week baby, his z-score is higher, right? It's higher. So that's why we choose A. Okay. Okay. Now number 11 is another question about the z-score. So it says 1 year Hank had the lowest ERA score of any male pitcher at his school, with an ERA of 2.82. Also, Amber had the lowest ERA of any female pitcher at the school, with the ERA of 2.94. Okay. And for Amber, she had 2.94. Okay. And we're given that for the males, the mean ERA was 4.515. And the standard deviation was 0.505. And for the females, the mean ERA was 4.734. And the standard deviation was 0.725. Okay, so we've asked to find the respective z-score and then determine which player had the better year relative to their peers. Okay. And in general, the lower the ERA is, the better the pitcher is. So first, we compute the z-score for Hank and Amber and see who got the lower z-score. Okay, and that person would be a better pitcher. Okay, so for Hank, his z-score is 2.82 minus 4.515 divided by 0.505. Okay. So 2.82 minus 4.515 and divided by 0.505. So that is a negative 3.36. All right, we keep 2 decimal places, so 0.36. And for Amber, her z-score is 2.94 minus 4.734 divided by 0.725. Negative 2.47. Okay, and since Hank, he has a lower z-score, right? Therefore, Hank, we choose C. Hank had a better year. Okay. Okay. So next one, number 13. Okay. Violent crimes include rape, robbery, assault, and homicide. The following is a summary of the violent crime rate, which indicates the violent crimes per 100,000 population for all states of a country in a certain year. Okay, we're given the first quantile, the median, the third quantile. Okay, so we said that what does the median? Okay, the second quantile is the median. What does the first quantile indicate is now 25% of the data, their value gonna be less than this number. Okay, and for the second quartile, or the median indicate is 50% of the data value gonna be less than this number. And for the third quartile, it indicate 75% of the data value gonna be less than this number. So that's why we choose C. So 25% of the states have a violent crime rate that is less than 272.8. Okay, and 50% of the states have a violent crime rate which is less than 387.9. Okay, and 75% of the states have a violent crime rate that is less than 528.3. Okay. And for the interquartile range, the interquartile range is given by the difference between the third quartile and the first quartile. So we do 528.3 minus 272.8. So we can find this answer. Okay. Okay. Interpret the interquartile range. So the interquartile range is a difference between this, and we said this indicates 50%. Okay, 50% of the data value gonna be between this. Okay, so that's why we choose B. The middle 50% of all observations have a range. Okay, have a range like this. Okay. The lower fence and upper fence So for the no fence, we said it equals the first quartile minus 1.5 times the interquartile range. So that's 272.8 minus 1.5 times the interquartile range, 255.5. Okay. Yeah, so it's a negative 110.45. And for the upper fence, it's a third quartile plus 1.5 times the interquartile range. Okay. The violent crime rate in a certain state of a country in that year was 1,496. Would this be an outlier? So we said if the value of data is less than the lower fence, or if it's greater than the upper fence, that will be outlier. So because our upper fence is 911, therefore yes, this observation is an outlier. Okay, and I guess some of you had a problem with part D. How to tell the shape of the distribution? Well, in class we said, if we look at the box plot, right? If the difference between the Q2 and Q1 and the Q3 and Q2 are equally the same, then the distribution is symmetric. But if they are not equal, for example, like this one, so the distance between Q2 and Q1 is, if it's greater than the distance between Q3 and Q2, this is a skewed left. This is skewed left. And if it's opposite, it's gonna be skewed right. So if we look at if we calculate the difference, so the difference between the median and the first quartile is 387.9 minus 272.8. So that's gonna be gonna be 115.1. The difference between the third quartile minus the median. Okay, that is 140.4. So if we graph this part, we're gonna have something like this. Right, this is my first quartile, this is my median, this is my third quartile. So we can see the distribution is skewed right, okay, because the distance between third quartile and the median is greater than the distance between the median and the first quartile. Okay. Okay. All right. So for number 15, the company data represented the miles per gallon of a random sample of cars with a 3-cylinder 1.0 liter engine. Compute the z-score corresponding to the individual who obtained 34.1 miles per gallon. So in order to do this, we will need to know the sample mean and the sample standard deviation. So we compute that part first. Now this is a sample standard deviation, so I select this. Okay. So the sample mean equals 38.95. And the standard deviation is 3.49. Okay. Yeah, I keep 2 decimal places. Okay. So this car has the data for this car is 34.1. Okay. So x equals 34.1. So the z-score equals 34.1 minus 38.95 over 3.49. So it's a negative 1.39. Okay. So how to interpret this result? So the z-score is negative 1.39. That means the data of this individual is 1.39 standard deviation below the mean. Because we said the z-score tell us how many standard deviation the data is away from the mean. If the z-score is 2, that means the data is the value of the data is a 2 standard deviation over the mean. If it's negative 2, then the data value is a 2 standard deviation less than the mean, below the mean. Right? Okay, then determine the quartiles. So we can do this using a StatCrunch. So we just select this, and we select the median, the first quartile, the third quartile. So you got these 3 results. Okay, 36.8, and median is 38.65. The third quartile is 41.1. Okay, and the interquartile range. So we found out the difference between the third quartile and the first quartile. 36.8. Okay, so 4.3. And how to interpret this result? So the range of the middle 50% of the observation is this. Okay, and the lower fence and the upper fence. Okay, so we use these two formula. We can find the lower fence and the upper fence. Okay, so that's 36.5 times 4.3. Okay, and the upper fence is 41.1 plus 1.5 times 4.3. Okay, so you, after you compute this, you will get these two answers. Okay, and then we're asked to see if we have any outliers in our data set. Okay, so we go back to our data set and to see if we have any data, the value that the value is less than 30.35 or is greater than 47.55, which we had 1. So 48.9 is an outlier. Okay. Right. Now next, number 21. All right. For number 21, we are asked to choose the correct box plot. For this problem, we don't have to graph the box plot. We can just see the answer from this data, because there are only 5 data, right? So the median is the middle one, 75. Therefore, okay, so this is gonna be 60. Right, let me make this bigger. So this part is gonna be 60. So this is 65. So the median is right, and this one 60, 65. Oh, okay, median also right. This one, now this the median is not 75. So C, we can drop C. Now between A and B, let's look at the what is the first quartile. So the first quartile gonna be the average between 59 and 66, because the first quartile gonna be the median of the first part, right? So and divide by 2, which is divided by 2, 62.5. Okay, so that's why A is not right, because according to this graph, the first quartile is less than 60, right? So that's how we know the B is right. B is the right answer. Okay. Number 23, the following data represent the dividend yields of a random sample of 28 publicly traded stocks. Okay, so first we are asked to compute the 5 numbers. Okay. So to find the 5 numbers, we select summary stats. Okay. So the 5 numbers consist of the minimum, the maximum, the first quartile, the median, and the third quartile, right? So I'm gonna select all of them. Okay. So the minimum is 0, the maximum is 3.63, the median is 0.8, the first quartile we keep 2 decimal places, so it's 0.31. The third quartile is 2.4. Okay, 2.44. Okay, and then decide which box plot is correct. Well, we can go ahead to drop C because the median is 0.8, so it's gonna be, so that's why C is not right. Also, we can drop A, right? Now between B and D, we can compare their third quartile, okay? Because third quartile is 2.44, so that's why D is not right. So we select, so we choose B. Okay. Now also you can you can find the answer by graphing the box plot. Right. Let me change this into horizontally. Okay, like draw the graph horizontally. Okay. So, okay, all right. Now, obviously, this distribution is not symmetric, right? And because the distance between the third quartile and the median is greater than the distance between median and the first quartile, so we know this distribution is skewed to the right. Okay, if the box looks like this, then the distribution is skewed to left. Okay. Okay, for 24, we are asked to graph 2 box plots. So let's do that. Yeah. Okay, after we open the data StatCrunch, go this box plot. So we select both columns. Okay. Oh. Now, if we compare this result with the given option, we can see the answer is C. Right? Now, for part B, does this appear to be a difference in the number of chips per cookies? Well, to answer this question, we're gonna look at their median. Okay. Why? Because the median tells me like what is like the average of the chips per cookie. Okay. So for the store brand, the median is about 23, and for the name brand, the median is 26. So I know the name brand has more chips per cookies. Okay. And does one brand have a more consistent number of chips per cookie? So to answer this question, we're gonna look at their range, because the range gonna tell us the dispersion. If the brand has a higher dispersion, then that brand gonna has a less consistent, because that means the number of chips per cookie is not consistent. Right? So by looking at these 2 box plots, we can tell the store brand has a higher range, so it has a higher dispersion, so it is less consistent. So that's why we choose A. Yes, the name brand has a more consistent number of chips per cookies. Okay. So how I'm gonna